So the question asks, use the computer output above to determine the equation of the least squares regression line. Identify all variables used in the equation. So I started with the predicted electricity. The hat means that it's predicted. This predicted electricity is found by the least squares regression line. The 0.137 is a constant coefficient found up in the computer output data. The 0.240 is the wind velocity coefficient, also found in the computer output. I then multiplied the 0.240 by the wind velocity variable. Wind velocity can change per problem. So for example, in question B, it uses 25 miles per hour and 15 miles per hour. You would plug that into the variable and get your predicted electricity. Question B asks, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles per hour? Show how you arrived at your answer. I started with plugging the 25 miles per hour into my least squares regression line. The predicted amount of electricity ended up being 6.137 amperes. I then went to 15 miles per hour and plugged it into my least squares regression line and got 3.737 amperes. But because it says how much more electricity, I subtracted the two and got 2.4 amperes of electricity. So you have 2.4 amperes of electricity more on a 25 miles per hour day than a 15 miles per hour day. C asks, what proportion of the variation in electricity production is explained by its linear relationship with wind velocity? So the proportion of variation in electricity production that is explained by its linear relationship with wind velocity is r squared. And r squared is 0.873. And I got that from the computer output.